Hey everyone, Chang here and welcome to my channel. Today we're going to focus on this formula. You guys can recognize this. This is the equation of ellipses. So with the F right here, hopefully you guys can guess, we're going to be focusing on foci or focus points, right? So here's the thing. Remember that when we're talking about ellipses, there's usually two common conditions of an ellipse. One where they're basically more wider horizontally, one of them where they're more wider vertically or more taller, I guess you could say, right? We still have our center and everything else is still the same. Now, in our previous video, which I'm going to link in the description down below, I tried to derive the ellipsis formula from a circle. But a lot of the time, the ellipsis formula actually is derived from the concept of foci or focus points. Now, what are they? Here's where it gets a little interesting. Now, when we're talking about circles, we need a center point and we have our radius. When we have those two, we're basically done. We know exactly all the information we ever need to know about that specific circle. Ellipsis is a little different. While we have the center point, which is wonderful, that's what we want, we really don't have this thing called a radius that we want, right? Because guess what? The distance from the center, let's just say, to one point all the way, and let's just say directly up there, right? It's going to be drastically different than the distance from the center point to, let's just say, about right here, right? The diagonal. And it's going to be different from the distance of the center all the way to, I guess you could say, the left or the right-hand side, right? So we don't really have something called a radius for ellipses. Now, I've learned the history of it before and I can't quite recall it right now, but basically, we ended up finding out that rather than looking at radius, there are these 2 points called focus points, or they call it foci, which is usually located in the left and right side of the center. Now here's the key. What are they? You can think of them as substitute for a radius because the idea is that with these two foci or focus points, right? If you draw a line connecting to some point on the ellipsis and then going to the other one, it doesn't matter where you connect it to the ellipsis. As long as you go from one focus point to the point in the ellipsis and to the other, the distance, the sum of the distance, it's gonna be the same, right? So that ends up being a substitute for radius. Now, is it really useful? Yes, there probably is a very good use for it, but just in terms of your general study, they're most likely just going to ask you about the focus point, how to locate them, and know what they mean. Remember, this again is just the fact that when you add the distance total, not just one section of it, right? The section is always going to be a little different. But when you add the total distance from one focus point to the other, left or right, doesn't matter, right? The distance itself is going to be some constant. So like a radius is some constant, this distance is going to be some constant. Now here's the other thing that's hecka weird, right? This right here tells us how to find the focus point, right? But it doesn't tell you the actual constant of the distance itself. That's a whole separate ballgame. And I haven't seen much problem to actually focus on finding the distance, or no, not the constant, right? They usually ask you to find the point itself, right? So that's why we're going to focus on this formula. Now, if you look at it, it can be a little confusing and a little weird. Why is there two of them, right? We have a squared minus b squared or b squared minus a squared. The reason is because, once again, we have two different variations. I don't like the fact that they do that, but I can understand why they did it. Because guess what? If it's this ellipsis up here, and we're talking about this, you have that vocabulary, major axis, minor axis. But this one, in this case, that means A, right? It's clearly bigger, right? Because A is in I guess you could say, corresponding to the x coordinate. It's clearly bigger than B, which is corresponding to the y coordinates. So, in this case, a squared minus b squared makes sense. Whereas if you flip it over and a is the bigger number, b squared minus a squared, you're going to have a negative number. And that's going to be a little weird. Well, that's usually useful for this one because in this case, clearly the y coordinates would be bigger and the x coordinate would be a little smaller. And you can hear my dogs right there not agreeing with this two notion of, I guess you say, focus points. All right, so here's the thing. While this is understandable, it's not that great. I actually prefer that you just remember one of the formula and understand a different, I guess you could say, concept of numbers. What do I mean by that? rather than trying to remember, oh man, in what situations I should use which formula because it could get confusing. Am I using a squared minus b squared or b squared minus a squared? There's two ways to go about it. Remember that always the bigger number minus the smaller number. That's one way. The other one is this idea right here. Every time you subtract the number, right, the order, if you mess with the order and it happens to be a bigger number minus a smaller number and you have a positive number, if you use the same number, the smaller number minus the bigger number, guess what? You're still going to have the same answer, but it's just going to be a negative variation of it. So for example, let's just look at a very simple case. 4 minus 3 equals 1. We know that. 3 minus 4, however, guess what? The answer is still 1, but it's a negative variation of it. So I actually like this, and using this, you don't have to actually remember two different formulas, right? You just have to remember that no matter what, the end result has to be positive. So if you happen to accidentally use a smaller number subtracting a bigger number, and you have a negative number, just get the positive version, because guess what? The answer itself is still the same. So that's what I think about this. Now, what does this actually give you? Once again, it doesn't give you that constant, not that actual distance, but it tells you based on whatever number it is and whether it's wide or it's tall, from the center, what is it? So if, for example, this is 4, right? Then that means the distance, let's just use this color right here. The distance from here to the first focal point is 4, and the distance from the center to this focal point is also 4, right? If the number here is 2, let's just say, for example, this one right here, it's probably not going to be 2, but let's just say there's the 2 focus point right here. The distance is going to be 2 right here, and the distance is going to be 2 right here. So just use your common judgment. If it's taller, then clearly the focus point is going to be, you know, up and down. Whereas if it's, I guess you say, wider, then it's going to be left and right. So other than that, I'm hoping that this is fairly simple. Now, the derivation of focus point, the formula itself is wonderful. It's amazing, but personally, I think it's a little tedious. Not really necessary, and you probably, I guess, succeed better with it, and it probably would be more efficient if you just memorize it in this case, because it's really not that difficult. It's just one of the squared minus the other squared. That's all. So I would actually, one of those rare occasions, recommend you memorize this formula instead of trying to remember where it came from exactly. Of course, understand what you're looking for, because I mean that's also very important to answering the question correctly. But other than that, memorize this. I think it'll serve you better that way. So with that, and with our recollection of ellipses, let's just practice on finding focus point and seeing if we can use this answer right here to find what they are. All right, so let's just start off with this problem right here. We have x squared over 25 plus y squared over 9 equals 1. And I've added this right here just in case, because here's our formula for an ellipsis. And if you forgot h and k, what it means is basically the coordinate for the center point. So we're looking at this problem right here. We notice that there's no h and k. So just immediately we can see that the center itself is at 0, 0. That's cool. Wonderful. Right? Now, the other thing is, if we really wanted to graph it, we can figure out a squared and b squared. Remember that in this case, this is your x radius and your y radius. So what's going to happen is that here, even though it's computed squared, right? We know that our a, let's just write it in red, a equals 5, and this one, our b, is equal to 3. They're both already computed. So if we really wanted to, and once again, I'm just only very briefly going over this. You have your -5, and then you have your 5 right here, right? That's your x radius, or whatever, I guess major axis in this case, because that's the bigger number. And then here you're going to have 3, and you're going to have -3, and then you draw your lovely ellipsis, and that's roughly what it would look like. Well, we don't really need to sketch it, but I'm just going to leave this here anyway, just as a reminder. But more importantly, what we're trying to do with this problem is to find the focus point. So here's our center. That means there's going to be 2 points. Once again, that if you draw it connecting to any point on the ellipsis, the distance is that exact same constant. So what do we do? Well, first and foremost, there's two formulas which don't really care about. All we know is that we want the bigger number minus the smaller number, if you can remember that. If not, just carry out the subtraction and get the positive variation. So for example, let's just say this right here is a squared, this is b squared. This is clearly the bigger number, so I'm going to do 25 minus 9, which gives me 16. 16 itself is f squared, which is our focus point. In this case, that's just going to be, well, if you take the square root of 16, that's going to be 4. And I'm going to show you what to do with this number exactly. Now, once again, the other scenario, if I forgot, and I just decide to do 9 minus 25, that's going to be negative 16. Ignoring that, the negative sign, once again, we got to remember it's positive because we're going to take the square root of it, right? The square root of 16 is still, once again, 4. Okay, what do we do with 4? Here's where we really have to understand what's going on with the ellipses. We know that the bigger number is on A. So that means, once again, it's wider than it is tall. So if that's the case, that means the focus point must be on the left and right of the center point, right? That's because it's wider. If it's taller, then it's going to be up and down. So knowing that this 4 right here means that from this, the center, we want to go 4 over here and 4 backwards as well. And these 2 points are going to be our focus point. Well, luckily for us, since this is center, right, if we move over 4, it's all on the x coordinates, so one of our focus points could be 4, 0. And of course, if we move over to the left, the other one's going to be negative 4, 0. And just like that, these are our 2 focus points using this formula. So let's look at a more complicated problem. All right, so this problem is actually very, very similar to the previous problem. Everything is the same except for now we actually have a center point. So the center point in this case is going to be 3, 1. Once again, I'm not going to draw the exact thing, but remember that we were working with a ellipsis that was wider than it is tall. It's not located in the center anymore. It's actually located, or the origin is located at 3, 1. But other than that, everything else is still the same. Our formula itself tells us that we just need the bigger number, subtract the smaller number. In this case, it's the same number, 25 minus 9 equals 16. That was squared, right? Remember, f squared equals a squared minus b squared, so we just want f. In this case, it's going to be square root of 16 equals 4. There we go. Simple as that. Now, rather than at first, originally, we had 4, negative 4 because we just looked at the center point and then we moved it based on what the major axis is. In this case, it was the x-axis, right? So, same thing. Now we're just looking at an ellipse where this is the center point. It's going to be 3, 1. Okay, but we're still going to be moving the same thing. So from here, we're just going to go 4 over and 4 over. That will give us our 2 focus points. Okay, looking at the x coordinate in this case, because we're moving along the x, I guess you could say line, right? We have, instead of 3, 1, it's going to be 7, 1 as one of the focus point. We're moving over 4 times. The other one is, instead of 3, 1, we're going to have negative 1, 1 because we're moving 4 to the left. And just like that, once again, once we find the actual f in this case for the formula, then we just look at it left and right, or in another case, up and down. Now, I talked so much about the idea of wide ellipses, and let's talk about tall ellipses. So of course, here is an example of one where it's going to be taller than it is wide. Same thing, we first look at the center. Center is quite simple. We should be experts at this, right? So we have here, this is a plus 8, which is not what we want. It's actually always going to be minus. Remember, minus h in the formula itself. So this is actually negative 8. And then here, we just have 2. So that's our center point. Now, we have to find the focus. We have f squared equals a squared minus b squared. But in this case, if we use a squared minus b squared, it's going to be 5 squared minus 13 squared, which is going to be negative. And once again, if it's negative, just make it positive, continue. If not, we'll just remember that the other variation, if this number is bigger, we're going to want b squared minus a squared. So in this case, it's just going to be 13 squared minus 5 squared. And that's going to be 169 minus 25, which gives us 144. Well, in that case, hopefully you guys know by now, 144 is technically just 12 squared, right? So 13 squared minus 5 squared equals 12 squared. In other words, our f in this case is 12. Cool. That's what we need. Now, what can we do next? We know that this is taller than it is y because the number here under the y, corresponding to the y radius, whatever you want to call it, right? It's going to be taller, and this is not going to be as wide, so it looks something along the lines of this. Okay, so we have our center, and in this case, our center itself, we can see from the formula, it's going to be negative 8, comma 2. My 8's not great. All right, cool. Now, rather than the focus point being left and right in the previous examples, this is because the major axis, right, it's going to be taller. The focus point is actually going to be up and down. But, same thing. It's going to be up 12. Wow, my penmanship is just off the charts today. And down 12. Okay, so rather than messing with the x-coordinate, we're actually going to be messing with the y-coordinate. So since this is our center, our focus point, which is going to be located here and here, right? It's going to be negative 8, and instead of 2, you're going up 12. That's going to be 14. Or going down, right? So it's going to be negative 8, and instead of 2, now you're going down 12. It's going to be negative 10. And these are going to be our two focus point coordinates for this equation. Now, of course, we're going to end the video with a problem that you would see in, I guess you could say, the wild, right? That you would normally see. It's not all nicely written in the formula or the equation of an ellipse just for you to gather all the information. They're going to give you something like this, plain and ugly. But we have the skill to solve this, so we're good. First and foremost, always organize it so that it's easier to see. Here's 4x squared, and I'm just going to organize all the x together. In this case, it's going to be minus 16x, and then I'm going to put y. It's going to be plus 9y squared plus 90y, and then we have our 205, which I don't really like messing with this, so I'm just going to bring it over. So what's going to happen is I'm subtract 205 on both sides, which is going to give us equals negative 205. Okay. Now, what we're going to do next is we're going to factor. And here's the end goal. I'm just trying to do completing a square and rewrite it so that it is in the form of the ellipses. So I know the information, I can work with it. Now, it's very similar to when I did it with the circle. So if you are not too familiar with what I'm doing right now, definitely follow along. And if you just want to see what happens and how I did that with the circle, I'm going to put a link in the description down below. It's very similar to how I wrote a format like this into the equation of a circle. This one's an ellipse though. So let's look at this. All right, well, with this, for the x, I'm going to factor out the 4. That means we have x squared minus 4x. And then it's going to be plus, and for the y, I'm going to factor out a 9. So it's going to be 9y squared plus 10y equals negative 205. Now, what I'm going to do is I'm going to complete the square for these guys so I can rewrite it. In this case, what's going to happen is you get what's in front of the variable with 1, the exponent 1, right? So in this case, it's going to be negative 4. You divide it by 2 and times itself. So in this case, negative 4 divided by 2 is just negative 2 times itself is just going to be 4, right? So negative 2 times negative 2 is 4. So technically, I'm going to add a 4 right here. And for this one, right, we have 10 in front of the y, so it's going to be divided by 2, which is 5. Times itself, 5 times 5, it's going to be 25. So I'm going to add a 25 right here. Now, before I continue, here's the caveat, and where a lot of people make mistakes. Even though I add a 4 and a 25, I have to do it on the other side. That's one thing, right? Because this is an equal sign, right? What you do to one side, you must do to the other. You can't just start changing and throwing numbers around. So that's one thing. The other thing is that what I'm doing is technically, I'm adding more than just 4 because I want to add it inside this parentheses to be able to complete the square and write it in a factored form, right? This parentheses is already multiplied by something on the outside. So rather than 4, it's actually 4 times 4. So in here, I actually have to add 16. Once again, one side to the other. That's this guy. This one, same thing right here. Instead of just 25, I'm actually adding 9 times 25. So if you guys can do your math very quickly, that's what, 225? So it's going to be plus 225 right here. So we have all of these before anything. All right, cool. Now, once they factor out, I'm going to save you guys the trouble. It's just going to be 4x minus 2 squared plus 9 times, what is it, y plus 5 squared equals, and this one add together very quickly, I think is a 36, yes. All right, there it is. Cool. And then now, what I'm going to do is I'm going to divide by 4 and 9 on both sides to get rid of what's in front. Let's just make it obvious. 4 times 9, I'm going to divide on both sides. 4 times 9. So what's going to happen is that in this situation, the 4 cancels and you only have the 9 at the bottom. In this situation, the 9 cancels, you only have 4 at the bottom, and this, of course, becomes 1. So we have 4, or not 4, right? They canceled. What am I doing? Okay, so it's just going to be x minus 2 squared with 9 at the bottom for this one, plus, and it's going to be y plus 5 squared with 4 at the bottom, and that's going to equal 1. Whew, we've done a lot of work, but now, this is what we want. This is your formula for an ellipsis. So I'm going to erase all of this, and then we're going to continue. So let's just, well, not all of it. Let's just do the top part. Okay, let's just bring this formula back up here. That is going to be x minus 2 squared over 9 plus, and it's going to be y plus 5 squared over 4 equals 1. Okay, cool. Now we can find the focus point. 9 minus 4 equals 5, right? That's f squared, so technically f is going to be the square root of 5. And here's the other thing. F is not always a pleasant number to work with. It's just a number. In this case, square root of 5, not a great number, but doesn't matter. Our center is going to be 2 and negative 5. Center equals 2, negative 5. Since this is under the x and this is the larger number, that means it's going to be wider than it is tall. So if that's the case, then we know that we're working with the x coordinate. Since this is going to be our focus point, we need to move from the center left and right. So if our center is at 2, comma, negative 5, right, we're going to have to move left and right, square root of 5 on both sides. So if that's the case, our focus point is going to be 2 plus square root 5, comma, negative 5. And the other point is going to be 2 minus square root 5, comma, negative 5. And just like that, we have our 2 focus point. That super long problem that I've erased went down a bunch of steps to rewrite it into the equation of an ellipse, and then after that we have our focus point right here. Alright, so we've reached the end of this video. Now, once again, focus points and its usage. It sort of replaces a radius. What I've shown you is basically for focus point, the concept is that you always have 2 points. It's either going to be left and right of the center or up and down on the center based on the condition of the radius itself. But the idea is that when you get from the focus point to any of the points on the radius and back to the other focus point, no matter which point you choose, it's always going to equal some defining constant. The thing that trips people up is, again, the formula itself doesn't tell you what that constant is. It just tells you the distance either from left to right or up and down of the center and to the 2 focus points. So that's what we wanted to show today. The formula itself is very simple. B squared minus A squared minus B squared. You have different ways of approaching it. If you want to memorize which one is which for the different condition, that's fine. Or if you want to remember, it's always going to be the bigger number minus the smaller number. Or if you want to remember, the answer must always be positive. So whether you got a positive or a negative variation of that answer, always just pick the positive one and work with that. The derivation, if you really want to, let me know, and I'm going to make another video focusing on the derivation of it. But for time's sake and for efficiency's sake, since it's such a simple formula, I think it's better that you memorize it instead of just trying to figure it out on the spot, right? Well, thank you for watching this video. Hopefully something as confusing as foci or focus points are made a little simpler. Whether you're going to see a lot of it or not is based on, well, what's happening in the real world, when you're going to see it in the wild. But normally, that's usually what they're asking, and then you will never hear about them again. Thank you for watching. See you in the next one.